The right-hand rule. The right-hand rule is a visual procedure that relates three perpendicular directions. We'll look at the general right-hand rule as it relates to vector cross products and right-handed coordinates. There's also two simplified right-hand rules, one involving an open hand and one a curled hand. So the right-hand rule uses the index finger, middle finger, and thumb of your right hand organized to be mutually perpendicular. As this relates to vector cross products, we would have vector A be, for example, your index finger, B the middle finger, and then the thumb would be the direction of A cross B. Now it turns out that A cross B is always perpendicular to A and to B, but it's not necessary that A and B are perpendicular. In fact, if A and B are parallel, A cross B is 0. In general, the magnitude of A cross B is AB sine theta. This can be interpreted as the area of a parallelogram with sides A and B. With AB sine theta, one way to interpret this is to take A sine theta separate from B and to see that A sine theta is the component of A perpendicular to B. Or we could leave A as is and say B sine theta is the component of B perpendicular to A. Now back to the right-hand rule. So if A and B are not perpendicular, then the fingers representing A and B, we would have to replace A, for example, with the component of A perpendicular to B, or replace B with the component of B perpendicular to A. And again, it doesn't matter which finger we start with A, as long as we go counterclockwise. So here you see A is middle finger, B is thumb, and that makes A cross B be the index finger. And finally, if A was the thumb, then going counterclockwise, B is index finger and middle finger is A cross B. Now, this also relates to right-handed coordinates where X, Y, Z would follow the right-hand rule. So we could start any finger in our right-hand rule as X, and again, as long as we go counterclockwise on our hand, the next finger would be Y, and then the next one would be Z. So here's an example where X, Y, Z is mapped to index, middle, thumb. And here, X, Y, Z mapped to middle, thumb, index, again, going counterclockwise on our right hand. Finally, we have X, Y, Z mapped to thumb, index, middle. Now, there's also a simplified right-hand rule that just allows you to keep the hand open. So instead of having your middle finger bend, just keep it open. Now, this is suitable for finding the direction of magnetic force on charges moving in a magnetic field. If we have the four fingers be the velocity of the object, and perpendicular to the palm is the magnetic field, then the thumb is the direction out of the page, and that would be the direction of force on a positive charge. Now, if the charge is negative, the direction of force would actually be the opposite direction to the thumb, into the board. Now, there's also another simplified right-hand rule, which involves a curled hand. So you would just curl your fingers like making a fist, but leaving your thumb out. So you sort of imagine X rotating toward Y, giving you this counterclockwise rotation that you grab with your right hand, and that then gives you the thumb out of the board. So positive Z then is that, related to a counterclockwise rotation in the XY plane. And this is suitable for finding the magnetic field lines associated with current or moving charges. If the thumb represents the moving charges or current, in this case coming out of the board, then the magnetic field lines are represented by the curling fingers that are these counterclockwise circles. So in summary, the right hand rule involves index middle thumb of your right hand organized to be mutually perpendicular. Um, and so if, for example, XYZ, if we start on the index finger, then X would be index, Y would be middle, thumb would be Z coming out of the board. The open right hand rule just straightens out the middle finger so your hand is flat and open. And then the last curled uh, right hand rule is where you sort of imagine X rotate toward Y, and as it's shown, that gives sort of a counterclockwise rotation, and that's then associated with Z, or the thumb coming out of the board.